We are starting with the managerial economics tutorial questions for the weekend and the evening student. So I'll be starting with the tutorial question 1. Sorry, tutorial question 2. Okay, so with the tutorial question 2, it states that the production function of ABC Company Limited, a manufacturer of paper towels, is described by Q is equal to 3K exponent 0.2, L is also exponent 0.8, where K and L denotes capital and labor respectively. ABC Company pays its workers a wage rate of 10 Ghana cedis, rent capital at 5 Ghana cedis per unit, and has a cost budget of ABC Company as 1,000 Ghana cedis. The firm sells its product for 5 Ghana cedis a unit. A. Determine the marginal rate of technical substitution of the firm. B. Determine the nature of returns to scale of the firm's production function. C. Determine the optimal amount of labor and capital that the firm should employ to maximize its profit. D. Calculate the profit of ABC Company Limited. Okay. So let's write down the equation. Okay. So we're given Q is equal to 3K exponent 0.2. L is equal to exponent 0.8. Now, the question stated that ABC Company pays its workers a wage rate of 10 cedis. So wage rate is the same as price of labor, and rent capital of 5 cedis. Rent capital is the same as price of capital. So wage rate. So we're given a wage rate. We know wage rate as W. Wage rate is the same as price of labor. Then we're also given rent in the question. Rent as R. Rent is the same as price of capital. Now price of capital is also PK. Price of labor is also PL. So let's go back to the question. So they gave wage rate to be 10, rent to be 5, price to be 5. So wage rate 10. So wage rate, which was W or PL, to be 10 cedis. They give rent, which is R or PK, to be 5. We were also given price. They gave price in the question to be 5 cedis. We were also given cost budget in the question. Cost budget is the same as total cost. So which is TC was given as 1,000 Ghana cedis. So wage rate is the same as price of labor. Wage rate we use W, price of labor we use PL, it's the same thing. Now, price of labor and labor, they are not the same. This is just labor. This is price of labor. So they are not the same. Labor as labor. PL is price of labor, either price of labor or wages. Then capital, which is K, is different from rent. Rent is R, so capital and rent are not the same, but rent is the same as price of capital. Okay, so this is the information that was deducted from the question. So with the A part of the question, stated that we should determine the marginal rate of technical substitution. So with the A question, marginal rate of technical substitution. So we are asked to determine the marginal rate of technical substitution. That was the A part of the question. So now, with marginal rate of technical substitution, it's giving us marginal product of labor divided by marginal product of capital, where marginal product of labor is equal to price of labor, or W, what we call wages, and marginal product of capital is equal to price of capital, or rent. So this is the formula for marginal rate of technical substitution. Now, per the question, we were given price of labor and that of wages. So let's go back. So there's it. Price of labor and what? Wages to be 10. Rent or price of capital to be 5. So with price of labor in the question, we were given 10. Price of capital or rent in the question, we were given 5. Now, what marginal product of labor and that of marginal product of capital was not given in the question. So it means we are supposed to calculate for it. So the first one, I'm calculating marginal product of labor. Which is MPL. Now with marginal product of labor, we are finding the derivative of the output function with respect to labor. It means that once I pick the output function, giving us Q is equal to 3k exponent 0.2 L exponent 0.8. I'm going to find the derivative of this function with respect to labor, because I'm finding for marginal product of labor. So let's continue. Now, we are finding the derivative of this output function here with respect to what? Labor. So it means that with this output function, we are just going to focus at the labor side, not capital, the labor side. So I repeat the same thing here. So this is 3k exponent 0.2. My focus is just the labor. Now, whenever we have this, per the rules of indices, the exponent here comes down as 0.8 L. Then that same exponent minus 1. That's the rule of indices. So we are going to apply that here. So open bracket 0.8 to the side L. That same exponent minus 1. So let's use the calculator. 3 times 0.8 give me 2.4. So I have that. You multiply the number by the number. So 3 times 0.8. Or you let me break it down. This is 3 times 0.8. Now the variable here, you repeat it, is 0.2. L 0.8 minus 1. would give us minus 0.2. So minus 0.2. Now 3 times the 0.8. 3 times 0.8 would give us 2.4. So MPL is equal to, this is 2.4. K exponent 0.2. L exponent minus 0.2. So this gives us our marginal rate of technical substitution. So this gives us our marginal product of labor. This particular one. So this is our marginal product of labor. Which is our MPL. So I'll do the same thing for marginal product of capital. So marginal product of capital. Which is MPK. So with the marginal product of capital 2, I'll find derivative of the output function with respect to capital. So I'll repeat my output function. It was given us 3k exponent 0.2, L exponent 0.8. So with this one, the first one was based on labor. This one is based on capital. So our focus is on the capital. So I have this. This is MPK. So remember the same concept. If I have a variable exponent 0.2, this exponent here comes in front. So I have 0.2 times k. Then that exponent minus 1. So 0.2 minus 1. So now I have this, open brackets, bring the exponent down. This is 0. This is k. That same exponent minus 1. This is, repeat back my labor because it's not labor I'm finding for. So I repeat it. My focus is just what? The key. So I'll only solve the key side. So now I have MPK is equal to, I have 3 times 0.2, which will give us 0.6. So this is 0.6. Now repeat the variable key. 0.2 minus 1. I'm doing the side, this one. So 0.2 minus 1 gives us minus 0.8. Repeat back my labor, L exponent 0.8. So this gives me my marginal product of capital. Which is our MPK. So now we know this to be the formula. The MRTS, per the MRTS, we had MPL divided by MPK, which is equal to price of labor over price of capital. Price of capital is the same as rent. Price of labor is the same as wages. So we substitute the equation to it. So the first one, it was 2.4k exponent 0.2, L exponent 2, have this 2.4k. Let me check the exponent. 0.2, L exponent minus 0.2. That was marginal product of labor. So this is the marginal product of capital, this one. So the marginal product of capital is 0.6 k exponent minus 0.8, L exponent 0.8 is equal to the price of labor and divided by the price of capital. It was given to us from the beginning of the question. So price of labor 10, there is it. Price of capital 5. So price of labor 10, price of capital 5. So we're asked to find the marginal rate of technical substitution, the A part of the question. So this is where you are supposed to end for the A part of the question. So I'm done with the A part of the question. I move to the B part of the question. So let's check out the question. So with the B part of the question, determine the nature of returns to scale of the firm's production function. So nature of returns to scale. So nature of returns to scale of the production function. So this is the B part of the question. Now, with the nature of returns to scale of the production function, with this concept, we derive this concept from what we call the Cobb-Douglas function. So this is what we call the Cobb-Douglas function. So the Cobb-Douglas function, we have conditions or the criteria underlining it. Either the criteria or the conditions. So with the conditions underlying it, it states that, now take note, this is capital, this is labor, this is alpha, this is beta. The condition states that if I have alpha plus beta and it's equal to 1, then it means it's constant returns to scale. Returns to scale. If I have alpha plus beta, which is less than 1, it means it's increasing returns to scale. Returns to scale. If I have alpha plus beta, which is greater than 1, it means it's decreasing returns to scale. So these are the criteria or the assumptions underlining the Cobb-Douglas function. So let's move back to our question. So with our question, we're given Q is equal to 3K exponent 0.2. Then I have labor exponent 0.8. So to determine the nature of the returns to scale, it depends on the alpha and the beta. So here lies the case. This number is our alpha. This number here is our beta. So let's add it per the criteria we have here. So I have A alpha plus beta, which is alpha was 0.2, which is this. Beta was 0.8. So 0.2 plus 0.8 will give us 1. So we would come in, based on the answer we are getting from this side, we would pick one criteria or one condition from here. So the first one is equal to 1 is constant return scale. And per what we did, we are getting 1. So the nature of, so it means this is what? Constant returns to scale, the nature. So the nature of returns to scale of the production function is constant returns to scale. So that's the B part of the question. I'm moving to the, let me add additional slides to it. Okay, so the C part of the question, let's go and check it up. So with the C part of the question, it states that determine the optimal amount of labor in capital that the firm should employ to maximize its profit. So the C, we are finding for optimal optimal amount of labor and capital to maximize profit. So this is the C part of the question. So before we start, so it means that in the question we are finding for labor. We are also finding for capital. That's what the question is asking us to solve. Okay. So now we move back to our equation. So this was what we had, this particular one. So let me, so 2.4 k, okay, exponent 0.2, 0.2, L exponent minus 0.2, all divided by 0.6, there's it, 0.6 k, 0.6 k minus 0.8, minus 0.8 k, sorry, L, there's it, it's not k, it's L, L 0.8. So we have L 0.8, which is equal to this is this whole thing that I'm picking to that side, this whole thing. So 10 over 5, I have 10 divided by 5. So let's solve it. Now, before you continue or before you start finding the optimal amount of labor and capital usage, we first have to use indices rule. I want to simplify it. So indices rule 1, it states that, the indices rule 1 states that if I have a exponent negative n, it becomes 1 over an. Also, if I have 1 over a exponent n, it becomes an. So these are the indices rule involved for the first thing we are going to do, this particular one. So the first number here is 2.4, so this is it. This is 2.4. The first variable here is k exponent 0.2, k exponent 0.2. Now, apart from this k at the top here, which is 0.2, we will check if we can find any other k at this particular side, any other k here. We have k at the down here, but it has an exponent of negative 0.8. So the condition or the indices rule states that if I have a variable down like this with a negative exponent, once it comes on top, it becomes what? Positive. So I have k exponent 0.8. It means that there's no more k here, so I'm left with 0.6. The variable left here is L exponent 0.8. I'll check if I can find any L somewhere. I have another L on top, but the L is exponent 0.2, negative. Now, if I have, it picks this condition. If I have a variable exponent negative n and I'm bringing it downwards like this, it becomes positive. So I have L exponent 0.2, which is equal to 10 over 5. This is the first indices rule. So indices rule 2, our second indices rule. So indices rule 2, it states that if I have a variable of the same base and they are multiplying, variables of the same base and they are multiplying, add their exponents, it becomes a exponent m plus n. So we bring back the equation here, this one, I bring it to that point. So this is, I have 2.4 k exponent 0.2 k exponent 0.8 divided by, let me check, 0. So 0.6 L exponent 0.2 L exponent 0.8, which is equal to our 10/5. So per the second indices rule, we will apply this second indices rule here. So same base, we add their exponent. So the number here, this is it. This is 2.4. Same base, this is k, this is k. So we add their exponent. So 0.2. So I have this k. This is 0.2 k, 0.8. Same base. So I'll add this exponent. So 0.2 plus 0.8 would give us 1. So it should have been this, but we don't have k exponent 1, so it's just k. So 2.4k. So the same thing, 0.6, same base, add exponent, so 1. So L exponent 1, but we don't write L exponent 1. It's equal to 10 divided by 5. This point, we just do cross multiplication. So I have 2.4k times 5, which is equal to 10 times 0.6 L. So 2.4 times 5 would give us 12. So I have 12k is equal to 10 times 0.6 would give me 6. So I have 6L here. Now, at this point, you decide to make any variable the subject. So I'm making L the subject. Make L the subject. So I have, let me add more slides. So you are making L the subject. We had 12k is equal to 6L. We are making L the subject. So we divide both sides by the coefficient of L, which is 6. So now I have 6 goes here 1, 6 goes here 2. Let's check it. Let's be sure. 12 divided by 6, which is 2. So L is equal to 2k. This gives us equation 1. Now, whenever you get to this point, you would have to pause and check the question. Check the question. If the question is using, we have two approaches. I'm breaking it down for easy understanding. Approaches. We have total cost, which is the same as cost budget or budgeted cost. Then we have the output as well. You have the output. So always you have to solve up to equation 1, but before you continue, it depends on the approach. So the question, you check if the question is using total cost or cost budget, or the question is using output. So let's check with this particular question. So with this particular question, the question is using cost budget, which is total cost. So it means that in solving this question, we are going to use the total cost approach. So if you are using the total cost approach, now this is the formula we are conversant with. Fixed cost plus variable cost times skill. Yes, this is correct. This formula is correct for total cost. But this particular total cost formula won't work in this question. So I can't use this formula. So this is the formula we use. Total cost is equal to price of capital times capital plus price of labor times labor. So this is the formula we are going to use in solving the question. Now with the output approach, we use the production function that will be given in the question. Production function is the same as the output function. So they'll always give it to you in the question. So with this question, our production function was Q is equal to 3k exponent 0.2, L exponent 0.8. I'm trying to make a brief analysis here for you to understand why I'm supposed to use this particular one and why I'm supposed to use this particular one. It all depends on the question. So with our question, we're giving cost budget, not output. So they gave us a total cost, which is the same as cost budget. So it means in continuing with this question from equation 1, I'm going to use this approach to solve it. So I move to the next page. So this is the total cost function. So total cost is equal to price of capital times capital plus price of labor times labor. So in the question, we were given price of capital is the same as rent. In the question, we're given price of capital as, let's check. Price of capital was given as 5. Price of labor 10. So price of labor is 10. And price of capital, so this is 5. And price of labor, or W, was 10. And that's in the same question. The cost budget, or what we call the total cost, was given as 1,000 cedis. So why is it easy? I fix the total cost, which is 1,000. Price of capital was given as 5, which is the same as rent, plus price of labor was given as 10. This is the L. So this gives me equation 2. So I will substitute equation 1 into equation 2. Equation 1 into equation 2. So I have equation 1 was, this is our equation 1, this one. L is equal to 2k. So L is equal to 2k. So I'll pick back the function. This is 1,000. This is 5. Anywhere I see L, I'll fix 2k. So this is 10. There's L here. So L, I'll replace it by 2k. So this is 2k. 10 times 2 gives us 20k. This is 5k. This is 1,000. So 5 plus 20 gives us 25k. This is 1,000. Since I'm finding for k, I'll divide both sides by the coefficient of k, which is 25. So k is equal to, so 1,000 divided by 25 would give us 40. So k is equal to 40. Therefore, we have capital, which is k, and the question has 40 units. So now we need to find for labor. So in finding labor, which is L, we substitute K, which is 40, into equation 1. Why equation 1? Because equation 1 was made the subject for labor. So equation 1 was L is equal to 2K, where now we have K to be 40. So L is equal to 2 times 40. L is equal to 80. So labor in the question as 80 units. So the this is labor. The previous one was capital. So we move to the next question. So that's all for the B part. That's all for the C part of the question. Optimal amount of labor and capital that maximizes profit. So let's move to the next question. So with the next question, which is the D part of the question, we've been asked to calculate the profit of ABC Company Limited. So profit, this is D. So profit of ABC Company Limited. So we know profit is equal to total revenue minus total cost. So we know total revenue which is TR is given by price times quantity. In the question, we were given price as 5 cedis, but we're not given output. So in finding output, I'll pick the production function. Why the production function? Because in the production function, that is where we were given the kill. So they said kill was equal to 3k exponent 0.2, L exponent 0.8. Now we solved it and we had k. We had k to be 40. We had L to be 60. So k is 40, L is 60. We would have to substitute them into this equation to get the kill. So 3 exponent 3 into bracket 40 exponent 0.2, 60 into bracket exponent 0.8. So 3 into bracket, I have k is 40 exponent 0.2, L is 60 exponent 0.8. So we have Q to be 165.98. So this is Q. So now I can find for total revenue. Since I know total revenue is price times quantity, so total revenue becomes the price in the question 5 times this. So 5 times 165.98 would give us the total revenue. So total revenue is 5 times 165.98. So total revenue will give us 829.9. So let's cross check with the production function. Let's check with the production function. Oh, sorry, we made a mistake. From this side, the L is 80. It's 80, not 60. So let's change it here. So the L is 80, not 60. Sorry about that. The L is 80. So it means this number will change. So we have to change this number and also change the number here. So L is 80, not 60. So we'll substitute them into, let me redo that side. We'll substitute them into the equation. So I have K is equal to, this is 3. L is 80. This is 0.2. No. So the first one here is K. Let me follow it in that order. So K is 40. So this is 40. L is 80. This is 80. Exponent 0.8. So let's use the calculator. 3 into bracket 40 exponent 0.2. I have 80 exponent 0.8. So Q here is equal to 208.93. So this is our Q. This is our output. So we can now find total revenue price times. So 5 times 208.93. So 5 times 208.93. So total revenue will give us 1044.65. So this is our total revenue. Okay. So we are still finding for the profit, because we know it's total revenue minus total cost. So in the question, we were given total cost, which is the same as cost budget, to be 1,000 cedis. So total cost, we had total revenue was 1044.65. 1044.65 minus the total cost, this one, which is 1,000. So profit is equal to 1044.65 minus 1,000. That will give us profit to be 44.65. So this is the profit of ABC Company Limited. So this was the last question, the D part of the question. Now, let me show you guys a trick here. We have what we call the proving technique. We know total cost function to be PKK plus PLL. In the question, we're given PK as, let's cross check it. We're given PK as 5. We know PK is the same as our rent, was given as 5. When we solved K, we had K to be 40. We had L to be 80. Then the price of labor, which we know is the same as W, in the question was given as 10. So we have to substitute everything here into the total cost function and see if we, since TC is equal to this, once we substitute everything here into this function, we should be able to get the 1,000 here that was given in the question. Once you're able to get 1,000, it means you are correct. But once you don't get 1,000, it means what you've done is totally wrong. So PK is 5. K we solved in the question was 40 plus PL is 10. L we solved in the question was 80. So let's do it. So 5 times 40, this will give us 200. 10 times 80, this will give us 800. So total cost is equal to 1000 cedis. So this is how we prove this. So it means what we've done is actually correct. So this is the first question I'm solving for the weekend and the evening school. Per your managerial economics tutorial question. That's our question 2. So I'll try and solve the remaining ones and also share it with you guys.